Landry. I'm glad it worked out for all of us. It's in addition to sharing what I have here about Bureau of Labor Statistics and in particular the Producer Price Index, I've also gotten an awful lot out of this last day and a half here. So from the presentations and also from my interactions with so many of you, and so I'm very grateful for that. It's good to get out of the office here. This is where all the magic happens. This is where we have a very nice building in Washington, right next to Union Station. We have about 1,600 or so economists, but also a lot of computer, technical people. In fact, it's probably the most common occupation among us in BLS is actually our technical. There's a lot of networks that we have to maintain, a lot of security associated with all of that. Very sensitive economic data that it moves markets. So I think you all understand the value of the security that's surrounded all that. So this is where we are. We are getting kicked out of this building in a couple years. Our lease is running out, and the government can't afford to keep us there. The neighborhood has gotten too nice for us over the 25, 30 years that we've been in the building. I've been at BLS for going on 23 years now, since 1997, and I guess I like it there. It's been rewarding, and I think one of the most rewarding aspects of it is seeing, like yesterday when we had the presentation on the data from the professor here at Texas, and to see our data being used and being able to inform decision making, and that's very gratifying to be able to do that. So this is and being able to interact with our data users is very rewarding. So this is where we are now, but like I said, if you know of anywhere that would welcome an agency of 1,600 or so eggheads, then let GSA know. The topics that I want to touch on today are mainly about the Producer Price Index, which has relevance to the valuation application that so many of you deal with, and I'll try to strike a balance between being very technical and being more general. So I'll cover some of the methodologies and about what it is we do and how we do it. We're very transparent with our methodologies, and then I'll in particular want to focus on what happens when we confront product change. And how we deal with that in the measures, and that obviously has quite a bit of relevance for you. So we'll compare some of the adjustment methods that we take there. So part of defining what the producer price is sometimes helpful to describe what it isn't. But there's a few key points here that I want to touch on. It's a voluntary survey that we conduct. So, and what we're measuring are average price changes that are received by domestic producers. So we'll touch on that a little bit more in a minute. And we collect prices for their outputs, so of goods and services. So we cover quite a bit of services industries too. So this is not a cost of living index. That would be more akin to the Consumer Price Index, which folks down the hall do. It is, you also heard yesterday mentioned the Federal Reserve's preferred consumer index was the PCE, the personal consumption expenditures or something along that. I forget exactly what it means, but there's different ways of measuring inflation, and so just to be clear, the PPI is more of an industrial measure of inflation. It is not an input cost index. We focus on outputs. There are some. Often they'll be very similar, but there's some important distinctions that are important. It is we collect it from the producers, not from what the buyers pay. And again, they're often very similar, but some differences there. The producers, for example, don't keep excise taxes or things like that. So, and the last one here is also particularly important, the point that we are not an import price index. So prices of imported goods are not included in the producer price index. And I'll talk a little bit later about where that gets a little gray, particularly with high-tech products. But generally speaking, we're an index of domestic production. So I just want to just drive home a few things here regarding the voluntary aspect of it. Firms that we sample and ask for prices from have the option of not cooperating. And unfortunately, that happens more often than we would like sometimes. So one of the challenges we have to deal with is non-response. And to the extent that the population that does not respond to our survey is different from the population that does, introduces the potential for some bias there. So we're collecting prices from people who agree, and the assumption we have to make is that they are also representative of companies that choose not to participate. So to the extent that that assumption is true, we're good. But when the non-responsive sample unit chooses not to respond, if their price trends are different, there's a potential there for some what we call non-response bias. So that's a challenge for us. I touched on this, the fact that we are domestic in scope, and we fully recognize that the disaggregation of production chains now, the global production chains, really complicate the notion of what exactly is domestic production. And this is particularly true for high-tech goods. So even within the US government statistical system, we don't really have always very good consensus on what that means. So the Census Bureau, which collects a lot of output data, has one approach. And in theory, we all have the same sort of classification system, but at BLS and the Producer Price Index in particular, we take a little bit of a more expansive view of what domestic production is. So in the case of tech goods, particularly goods that deal with either storing information, processing information, transmitting information, communications devices, the view is that to the extent that that product is researched and developed and prototyped and quality assured in US locations, the fact that it was actually fabricated overseas, it doesn't necessarily disqualify it from us including it in the index, because we in our view, the value of the product derives primarily from activities that actually do occur domestically, and that the fabrication of the device or the chip or whatever is almost incidental to the value of the product. Not entirely, but the plurality or the majority really of the value comes from the information embedded in the product, either in its design or in its function. So that's one thing to keep in mind. And then finally, again, this is we collect our data from the goods producers, the manufacturers, the service providers. So it's from their perspective that we are collecting the prices. We're not collecting them from what people pay, the buyers. And you'd think in theory they'd be the same, but there are some subtle differences, and I'll speak to in a minute about why the output perspective is important. So just some history. The PPI goes back a long time, back to the turn of the 20th century, I guess, early 1900s. Congress was looking at the effects of tariffs, curiously enough. So this is a story that is starting to repeat itself. And so for many years, we were known as the wholesale price index. That terminology now sort of migrated now into this producer price index in recognition of the fact that we cover a lot of service industries now. We cover mostly all of mining and manufacturing with some exceptions, and about 3/4 of the service sector economy. We cover in terms of, we talk in terms of industries, and the industries that are defined by this, what referred here as NAICS, which stands for the North American Industry Classification System. Some of you may be familiar with that. But it's basically a way of grouping businesses that produce or use similar processes into something called an industry. So from those 600 or so industries, we have about 17,000 or so companies, firms, sometimes you might hear me refer to them as establishments, that we go out and collect prices from. So that's the basket of producers, and those producers provide to us about 60,000 or so observations on actual items, so unique goods and services. And we are a monthly index, so there is a timeliness aspect to our work. The data that we collect from all those thousands of observations is aggregated into 10,000 different indexes that we do publish monthly. And these indexes take two main presentations, or two views. One is on the basis of how we've collected it along the industry line. And so these are products that are made from one producing industry. Of course, the same product can sometimes be produced in multiple industries. So we re-aggregate the data and publish what are referred to as commodity indexes. So where you have the identical product can be produced in different producing industries. So a simple example is refined sugar, which can come out of a sugar cane mill, most of those down in Louisiana. And those mills produce refined sugar, and there's another industry that's the sugar beet mills that up in the upper Midwest that use sugar beets to produce the same exact product. So if you're a data user and you want to know what the price trends are for refined sugar, you want to use the commodity index. And that's generally true for your applications as well, that to the extent that the products that you are trying to track and follow, the better index, the recommended index presentation would be our commodity series. And I can talk a little bit more about that, that later. Some of the main uses of PPIs are, of course, for policy making, so these macroeconomic considerations, and they also as a foreshadow of consumer inflation, although sometimes that link is not as strong as we think it might be in theory. That we don't the producer price index doesn't necessarily predict very well consumer inflation. A big part of that is the fact that we are not accounting for imports there. So the first two here are really very macroeconomic kind of considerations. The national income accounts, or the gross domestic product, the GDP, uses our data to deflate industry outputs. Same for productivity. So it's turning nominal values into real values to account for the effects of inflation. And the same is true for the more micro uses of the data, which are these few at the bottom here, the contract escalations, where if people are construction firm is building a steel bridge somewhere, they want to escalate their contract, writers in their contracts to say, the amount you pay me is going to differ based on the price of steel or concrete, some of the inputs that are needed in order to execute the contract. Accountants use our data for LIFO, last in, first out valuations, and of course, the ad valorem aspect of it, the usage that you all have for assigning value to assets. I'll jump in a little bit here on the theoretical model without getting too deep in the woods here, but the producer price index is what's referred to as a fixed input output price index. So I mentioned you can measure producer prices from the perspective of the producer or the buyer. So we use the perspective of the producer here. And the point here is that the assumption we make, economists love to make assumptions. The assumptions in the model are that factors like labor, capital, technology are all fixed. And so that when the revenue of a firm changes, it's the prices that they are receiving are the thing that actually affects the revenue of the firm. So if all these factors of production are held constant, only the changes in the price of the output is what gives direction to the revenue of the firm. And so this is obviously a big assumption here too. We know these things all change. We know that labor and capital and technology all change. So we have to be able to account for, in the real world, when those things do change. But the theoretical model is that everything is held constant and it's price change that we are observing. And the numbers that we put out are not prices per se. They are index values. So early in the PPI history, going back into 1920s and 30s, you can look back at some of our old publications, and they will actually have prices for buggy whips or whatever, and other obscure products of the time. But in the modern era, we are certainly publishing index values, and the formula that is used here is referred to as a Laspier's formula, which basically, in order to do an index, you have to have a weighted average. And it's not just the price observation that we have to consider, but also we have to give that observation some weight. So if we're imagining we don't want to assign, if the value of apples is 3 times the value of the strawberry crop, we want to make sure that those two commodities in our indexes are appropriately weighted, and we adjust the prices according to their weight. So this QA bit here, and you'll notice it's the same in every time period. So we assume that those weights are fixed, and so that the market share of apples is fixed relative to the strawberries. Now, of course, that changes. So over time, which is why we say we're a modified Laspier's index. Laspier's refers to the fixed quantities. So we do update those quantities, and this is the value. This Q piece is something that we get from the Census Bureau. We do our weighting in 2 stages. So the first stage of the computation is weighting the output of an establishment. They produce in various product lines. So a sporting good manufacturer might make golf clubs and tennis balls, and golf clubs are 70% of their business. We want to make sure that when we weight their items, if we collect a quote for the golf equipment and the tennis equipment, that we weight the golf equipment appropriately. So the first stage is collected of information that we collect from the respondents, according to the business's relative share of their product lines. And the second stage of the index calculation goes back to where we use the census data, which is collected every 5 years by the Census Bureau. And so this is how we know how to weight, say, sporting goods relative to steel outputs. Steel outputs being much greater needs a much greater weight in our indexes than sporting goods. Before I move on, any questions on the weighting aspects here? And if you have questions as I'm going along, please feel free to ask them as we go along. I'll have some time at the end too, hopefully, but please feel free to shoot. So I wanted to just take a look at some of the industries that are relevant to the topics being discussed here. So these industries are given, these are these NAICS codes, this 334, 210. And this is a hierarchical system. So 334 refers to all of electronic and electronic equipment. And the 3342 refers to communications equipment generally. And so at the 6-digit level here, this 334, 210 refers to telephone apparatus manufacturing. And within telephone apparatus manufacturing, there are 3 product lines that are identified. And I've put here, this is using 2012 economic data. The 2017 data should be coming out soon this year from the Census Bureau, and so we'll update this. So this gives you a sense, getting back to the weighting discussion. So when we go to calculate our indexes for this industry, we will assign wireline and voice and data network equipment about 52% of the weight of this index that we do for 334, 210. And again, I guess I'll mention this is domestic. This is domestic production. Some of this may look a little different from what you might expect it to look like, but this is for domestic production that Census Bureau.
One question.
Yeah, let me go back to
2012. Is it every 5 years that you update it from census, and then it's a couple years behind that?
That's right. So this year, in 2020, Census will be releasing data for the 2017 year. So they have to wait till the end of 2017 before they go and take the census. And the companies then have a long time to respond. So that in 2018 they start getting the survey forms from Census so that they can report what it was they experienced in 2017. So it's a long lag. We were always trying to find ways to shorten that gap and make it more relevant and timely, but there's just a lot to it. So once Census will release this data then for 2012 this year. By the time the producer price index gets around to actually re-baselining our weights, that might not be until 2022 at this point. So it's not an insignificant gap there, and it's something we recognize, and we try to do things to mitigate those impacts, but this is what we are working with. This is a similar chart here for a different industry, 334-220, which again covers broadcast and wireless communications equipment makers. And you can see here there are 4 product lines that are included in this industry. The radio station equipment had been significant. This other group includes things like point of sale terminals and other other communications equipment. It's sort of a catch-all category of things. But I was kind of surprised when I looked at this that wireless was relatively smaller. I think this may get at some of the distinctions that here again about the way census observes and recognizes this activity, and essentially they view some of these companies as wholesaling activities, where they're just importing the finished products from overseas, even though a lot of the work is being done here to develop those products in a research and development capacity. So this is just, I put this up just to illustrate where we get our weightings from and how that might affect.
And the BLS is value of service, but what is that in a dollar amount?
So the question was about the value of shipments here. Those are dollars, yes. So this is a almost $25 billion industry, and the telephone apparatus was roughly a $7 billion industry, as recognized by census in 2012. So I want to talk a little bit about the process that we use for sampling. So we don't collect prices from every business in the country. We have to take a sample. And that sample is done on this industry basis again. So we're using the NAICS classification for that. And the universe that we make these selections from is from the unemployment insurance system. So every business has to get a file in this unemployment insurance system. And this is convenient for us to use at BLS because other parts of BLS maintain this business register. So the US has actually two what are referred to as business registers. The Census Bureau has another one, but it has a lot of tax data in it, and we want to kind of avoid that for a lot of reasons. But it's mainly to sort of step away from taxation aspects, and so that when we go to approach companies, they know that we don't really have anything to do with, that we're not trying to tax them, that we're not trying, basically we're strictly there for statistical purposes. And so this is convenient for us, and we make our selections. We assign a probability to every unit that's in this universe, and that probability is proportionate to their size. So companies that are larger are more likely to be selected in the sample, which makes sense. And the measure of size that we use is employment, and so employment is a proxy for their output. And these baskets for each industry are rotated about every 8 years. Some industries need to be resampled, as we say, more frequently because they experience high rates of entry and exit. So if the barriers of entry to an industry are low, you might see more churn in the composition of establishments that are in an industry. So we want to make sure we resample that a little bit more frequently. Also, industries that see high rates of technological change, so there's a lot of product change mix. We want to make sure that we hit those a little bit more frequently as well. So telephone apparatus, the semiconductors industry, those industries we want to do a little bit more frequently. Other industries in my area are mining sand or construction sand. The product has been the same for a while. It's not changing. There's not as much dynamism there, so we can let those industries go for a little bit longer. In terms of our data collection process, it happens. There's two events here. There's the initiation of a new unit into our sample, and this requires a visit by a field economist. So we have economists around the country who go out and actually visit the units that have been selected and solicit their cooperation. And in that process, they are identifying product attributes that are important for determining price. So these price determining characteristics. We want to make sure that we identify these so that when we, in the next stage, this monthly stage, where we send out the request for them to reprice, as we say, to send in their prices, we want to make sure that we've identified the products very, very specifically so that they're a unique product and that the attributes of that product are described so that if one of those price determining attributes changes, it's a signal to us that something has happened here. There's been a change to the product which we need to evaluate. And so somebody in the Washington office then will intervene in those cases. So we'll talk a little bit more about what triggers those reviews and what kind of techniques we use to identify them. But in this initiation stage, I'm pointing at the monitor as if you can see that. In this initiation stage, it's important for us to really zero in on the characteristics of a product that drive its price. So when we do encounter product change, we want to make sure that we isolate the factors that are different about a product from actual real price change. So that the index changes in index movement are related to changes in price, not the attributes of products that have changed. So we want to try to remove those effects, those quality improvements that have happened. We want to maintain an index that we refer to as constant quality, so that in the case of a new car, and we'll look at an example. A new model year has, as Augie was saying, some of these adaptive technologies or assistive technologies. Each model year now they're coming out with more and more features, and those add those add cost to produce. So they're adding new quality. They may have higher prices, but there's a lot more value there. So we want to make sure we account for that new value, and then we don't just compare the old price with the new price without adjusting for those quality changes. And so this maintains fidelity to that fixed input-output model, where we made those assumptions that these factors of production were going to be fixed. And when we get a new model, those assumptions are violated, and we have to intervene. So I want to talk a little bit about some of the, a topic I know that would be of interest to this group, and is what do we do? How actually do we intervene when we encounter a new product? So these are four methods. There are others that are variants of these, but these are the main four reasons or methods that we use. And the first three here are all variants of what we refer to in the literature as matched models. So we're comparing an incumbent product with a substitution product, and so it's a direct link between one product and another. We also are doing some modeling, which is not so much a matched model approach. Let's look at each of these in detail. So the direct comparison approach is when the product change is fairly minor. And so the example here is a dress was a blue color and now is red. This does not fundamentally alter the quality of the product. It's just a different color. It doesn't affect the cost that's experienced by the manufacturer to produce it. I'm assuming blue dyes and red dyes are roughly equivalent in price. So there's nothing substantial here that we need to address. So we can compare, to the extent that there is a price change between these two, we can attribute it all to inflation. It's all price change to the extent that there is a difference in these two prices. The color of the dress is not what we would refer to as a price determining characteristic. So this is a easy case. Not too hard. Of course, there's other examples in the case of an automobile, as we're talking about, where there's every October, and it's not even just October anymore. It's October and November. They're rolling out new vehicles, sometimes as late as the new year. But typically, in historical terms, the new model year was in October, and they would introduce new trim lines, new safety features. A whole host of different kind of powertrain options and so forth. So these are not directly comparison. We can't directly compare one model year change to the next. We have to intervene and do some adjustments here. And the first fallback here for us is to approach the manufacturer and ask, well, what was the difference for you to produce the old model compared to the new model compared to the old model? And so the automaker may tell us, well, and the automakers are actually pretty good about this. They know exactly how much the extra screen is now in the console and the electrical system. These mass producers know per unit very well what the unit cost is on all these additional features. And to the extent that they give that to us, we can make very good explicit adjustments here, because the respondent has told us these new features cost, well, let's look at an example here. We assume a car increased from 1,000 from 20,000 the year before. But the respondent tells us that $1,000 difference, $800 of that is associated with new safety equipment that's in the vehicle. So we can't then call that inflation, because there's value there that we need to account for, and we can't just directly compare. So the price change that we want to reflect in the index really is just the $200 that's not accounted for by the quality change. And so instead of inflation being 5%, if we were to directly compare it, the price change that we're going to reflect in the index is just 1%. In the case of when the respondent is not able to give us that explicit quality adjustment data, and the products are too dissimilar to compare to each other, then we have another fallback that we go to, and that we refer to as this overlap comparison. And here we assume, and we have to be able to collect prices for the incumbent item and the new item in the same month. And we have to be able to observe a price during what we refer to as this overlap period. And this sort of looks like this, where we have this old model. The price in March is $1,000. In April, it goes up to $1,050. So we see a 5% change in the index. In May, it goes back down to 1,000. So the index readjusts back down again. But in June, this model is discontinued, and so the economist in Washington will call the company and ask, what's the new model? Do you have a replacement in your product line for this model? And they say, yes, we have this new model, and it costs $2,000. Well, actually, we'll start in June. It costs $2,200. But so we will then ask, well, how long have you been producing this new product? And they say, well, it's been on the market a month or two or three. And so we'll ask for a price. Well, what was the price in May? So this allows us then to to reflect the price change of the new item in between May and June for the June index. So this item, since we were able to observe that it had a price in the previous month of 2,000 and now it's 2,200, we can say that we can show that there's a 10% price change for this product based on information for the new model, because we were able to observe in May prices for both the old and the new. So this is something that we commonly have to resort to in the telecom area, because these are very complex systems. There's not a whole lot that these are very, very complicated bundles of systems, and so they're very hard to make comparisons for the respondents. Really don't often know how much more it costs to produce one model or the next. It's just not. They're too different. They're too dissimilar in order to be able to make those kind of comparisons. Unlike the auto example, where you have a new model year, they started on the basis of the old model, and assuming it's not a complete redesign, then we have something more like this. But those stepwise changes are a little bit easier. When you have a totally different bundle of product, then we use this model. So here, there's a potential for bias to the extent that if we are understating the impact of those quality improvements, so here we assume that that the entire difference between the 1,000 and the 2,200 was entirely due to quality change. We wrote it all off so that we would not show any price change, except in the case here that we knew that this model actually had a different price in May, and so we were able to make a comparison. But if this had been 2,200 in all these months, the index would have shown zero change, because we would have assumed that the entire difference between these two bundles was entirely related to the quality of the product, the value of the product. So to the extent that that new product actually had even more value associated with it than we are reflecting here, then there's a potential for an upward bias in the index here if we understate that comparison. So our challenge here is to get those values right, and that's sometimes when we turn to these hedonic regression models, where we recognize that there may not be a very good relationship between the cost to produce an item and the value. So and this happens in technology goods, where there actually are often declining production costs over time, and at the same time the products are getting better and better. So here is where we turn to econometrics and running regression models when the resource cost method that we ordinarily would take doesn't really apply very well. And these hedonic models you look at relationships between the characteristics of a product and their price. So you use this for computers and servers, and you can see here some of the characteristics of the product that we use to model: the speed of the product, the capacity, the storage capacity, operating system, graphics, screen size. These are sort of the attributes of computers and to some degree servers that we can use to set up a model. And this is what the functional form of the model looks like, where the price is a dependent variable, and the variables that explain the price are all these coefficients, which are stand-ins for some of these, in the case of computers and servers, are these attributes here. So what happens in this case is that there is a price associated with each component of a product. So the memory contributes so much to the overall price. The speed of the processor, the type of operating system, all these things are assigned through these regressions a coefficient, which is essentially a stand-in for a price. And you sum all those up, and you get what the price is that we would show in the model. So this is a technique that's been very, very helpful for us in computers and servers, desktops, laptops. We're also starting now to apply this to microprocessors, or a variation of this to microprocessors. But there are some limits. There are some constraints that we face in applying this technique more broadly. And some of them are related to resource, and some of them are related to methodological concerns. These models take, frankly, more staff time to develop and maintain and gather the data. Sometimes the data that we need actually costs quite a bit, and we're getting our leadership to recognize that we need to spend some more money on buying big data sets. That's where we're heading, but there's still some issues there. The timeliness is also important to us. A lot of times these data sets are available after, we're a monthly index. We have to put out something every month, but sometimes the data sets that we need in order to be able to do that are on a lag. So sometimes reconciling that tension leads us to not use these modeling techniques. We also need a sampling size that's large enough in order to be able to do the model. We are working on some techniques that maybe get around that a little bit, and I'll mention that in a minute. But that's also another factor. And telecom products are also much less mass-produced than computers. So, and there a lot more customization there as well. So that makes it a little bit more difficult to use this technique on telecom products. Some of our future work that we're looking to do, and I'm blessed with some really smart people who are doing this in my area, and it's gotten to the point where I rely on them quite a bit, because some of these techniques are quite sophisticated, at least for us. But so as I mentioned, we're starting to apply this modeling to microprocessors. Interestingly enough, we started a couple years ago with it. We haven't really noticed much of a change. The microprocessors index used to go down very, very dramatically, but then the last few years it's really gone. It's a little bit lower, but much flatter than the declines that we saw earlier in the late 90s and early 2000s. We have some research ongoing that has application to network switches and telecom goods in using these referred to as out-of-sample validation techniques, which will help us address some of the problems that we have about small samples, using other sets of observations to help us inform what our models should be. And we have some people who have written recently on that. Brian Adams and Alex Clayman have a paper out in our journal, the Monthly Labor Review, that explores some of their work in this area. And I just also wanted to mention too that we do use a hedonic model for broadband services, which may have some relevance here for you as well. So this isn't dealing so much with the equipment side of things, but the service provision. And as I was watching some of these presentations yesterday, I was thinking about some of those, particularly the not all 5G is 5G. If we ever got to a modeling there, it seems like it makes a big difference of what point of the spectrum are you getting that 5G service on. So as I'm observing these presentations, I'm seeing an awful lot of factors that may contribute to price determining characteristics that we would want to consider when we're doing our modeling. So I made quite a few notes on that. But so we are continuing to benefit from, as I say, your input from our data users, our academics that we work with, but also industry experts. And so, part of what I hope to get here too is some feedback as well. And so I welcome all of your comments and thoughts. And doing price change for these types of goods, measuring that is a challenge. You face the same challenge in doing your valuations, and just as people will say your index is moving too high. Other people say your index is moving too low. There's it's trying to strike the right balance between that and do it in a methodologically sound way that we can replicate as well. Those are some of the foundations there. So I thank you all and would welcome questions. Rosella, let's get your mic there.
Yeah, so you just on the previous slide had a couple individuals' names, and you mentioned they publish papers in, is it an academia world or your world?
It's well, the Bureau of Labor Statistics has a, I'm going to see here if we have the links on the notes page, but yes, we have a journal called, it's published. It's the Monthly Labor Review, and if we have they put out a paper a few years, it was 2018 maybe now, on some of the techniques that they're researching to help us define new ways to define models and to validate models. Because you can run a model and it'll tell you things, but is it right? And so this is some of the work that they were doing. I'd be happy to share that with you. But it's a Monthly Labor Review. It's a publication of BLS.
Quick question for you.
Yeah.
So if I understood all the different models and the potential for bias, if I can use a mouth, right, for inflation and deflation, are you telling me that on inflationary, your bias is a little on the lower side to make sure that you take a conservative position, and the same thing would be on a deflationary, it would be less deflationary than maybe actual, as that's going in opposite directions?
I think there's certain factors. I guess there's the potential for bias in either way, and it's hard for us to know what whether it's there or not, because we don't have necessarily the counterfactual. There are as I mentioned, there's people out there at the Federal Reserve in particular. Some of you may be familiar with the work of Dan Sichel and who's the Dave. Anyway, I'll think of it in a minute. But where they're saying your indexes are not going down enough. So in other words, we're overstating inflation. And then there's other critics out there who look at our data, particularly for that 334, that electronic goods area, and they're saying, if you guys are overstating the price declines here, that you're overstating productivity, and so there's people on both sides. I don't know that there's a systemic bias one way or the other. I think generally we think we're probably, if we had to guess, that we're probably overstating a little bit, and some of these techniques are trying to get at ways of our assumption is that these techniques will help us reduce that overstatement. But as we've been using them now a little bit, it's particularly in the case of microprocessors, it's not going down as much as we thought it might. There hasn't been this directional change before and after using these techniques as much as we thought we might see. there's, some of this we heard about Moore's Law yesterday too, and, I think there's some question, we're seeing ourselves and we're seeing also in media that, maybe we might be running up against some physics here, that there's only so much heat that they can dissipate in these processors. There's only so much they can do with silicon before they have to find some other material. So we're seeing some of this now. We're kind of curious about whether or not the physics of this we're bumping up against some physical limits. Ruben, yeah.
Oh, this is an easy question. What is your role at the BLS? I mean, there's 1,500 people. It's quite a machinery. I'm just curious.
Yeah, so it's a good question. So I oversee a staff of about 20 or so economists, and we divide ourselves up along industry areas. So we believe there's some benefit to coming from specialization, and so those industries is, again, they're along NAICS basis. So I cover. So my staff covers prices. I have three teams. One team handles metals and metal mining and some miscellaneous manufacturing. I have another team that handles transportation and equipment, and then a third team that handles most of these tech goods, the electronics and electrical components. And I think at BLS you have there's a couple different paths. You have some people who go down a very technical path, and another path who does more managerial type thing, and I guess I'm more of in that path. So not quite as technical as some of the people that are in my section, who are doing some. I'm really blessed to have some guys really and gals too, who are doing some really great work, and know how to reach out to other areas in BLS where we have the PhD economists who are doing index number research and really advanced sort of things. So and so my role is to kind of harness all that, make sure we're addressing some of the data user needs, being aware of some of the trends that we have to be mindful of in terms of, and also, we have this tension between having lots of very detailed data and for the areas that we do cover, versus covering a lot more breadth. So there's some segment of our data user community that mainly in other government agencies, that want us to cover a whole lot more space, more broadly. And then there's this whole other data set of users, and I would include most of you in this group, that value the very detailed indexes that they want on with a lot of granularity. And so it's trying to balance those two needs. I spend a lot of my time with that. I work a lot on classification issues as well. Did I sort of get it?
Follow-up.
Yeah.
Is it just PPI that you guys work on, or do you work on the labor costing?
My area does just producer prices. BLS at large, there's certainly other areas of BLS that do the labor costing and work on those programs. And we do work together. We work a lot. There's a lot of overlap with our productivity measures. So we have a lot of interaction with people that work in our productivity office. But specifically, my area does producer prices. Yeah.
Any other questions? Or I've got one quick
Yeah.
one for you. Evaluation appraisal work, a lot of what we're trying to do is take a piece of equipment that's older and try to compare it to what it might cost to replace the same functionality with new equipment. And so the way you do it, might use it a price index, but then we might also account for the performance changes in the new technology. And if I wanted to apply your indexes, it sounds like for a computer or a server, I wouldn't make two adjustments because your price index already adjusts for the part improvement. But if I was looking at a piece of equipment that was providing wireline service, for example, that improvement might not be cooked into the index, or at least not in some trend way. You might have accounted for it in some qualitative fashion. So how do I know how much additional adjustment to apply as opposed to just looking at the price change?
And I guess we would say the index, you could use the index value there, that, you know, we are, to the extent we can, based on the available information to us, either from the, you know, from the respondent or through some modeling techniques, we are accounting for those quality changes. So when we do encounter a new set of equipment, and we can't make a sort of a resource cost in terms of production cost adjustment, we will assume that all that value the difference in price is related to quality, so if it has a higher price, we'll assume that higher price is entirely accounted for by the quality change of that product. So the index is not going to go up in that case. It might just be level. Okay. What we might be missing is the case where the quality is actually, the product is going, the price may be going lower, in fact, but the quality is going higher. And that's when those two things diverge, which is not uncommon in technology areas, then we have an issue.
Okay. And how does one from the outside find out?
It's not going to be. I don't know that it's transparent there in that case. I don't really have a very good answer for that. I mean, what I will say is that when we do think we encounter that situation, we try to avoid it. In other words, you know, if we know it's there, we're gonna make an adjustment. We're going to you know, we'll intervene to the extent we have some information that situation exists. So if we're aware of it, we're going to address that. It's just the cases where maybe we aren't aware of it. So this is where that industry expertise from I mean, on my staff's perspective, you know, they have to really know what's going on and have an antenna, you know, no pun intended here, but for what's going on in their areas.
Okay, very good.
So one other question, when you talk about U.S. versus foreign,
So can you give me an example, or my example maybe, an Intel would be a U.S. base. You would consider that, although it's produced offshore. But Ericsson may not be part of the mixture because it's foreign and produced off?
Yes.
Thank you.
Let me. I don't mean to be coy. I'll try to avoid using specific names because you know, part of the bargain that we make with our survey respondents is the anonymity and all that. So, but you know, the question was, you know, a company like Intel that is based in the U.S., are more likely to have a company like that in our index because of the activity that they perform here in the U.S. as opposed to Ericsson, which is Swedish or foreign based. Is that right? Swedish, I think it's. That would be great. Now, if those companies actually have U.S. operations that contribute significantly to research and development, and then it's possible we could find that they're in the sample. But generally speaking, I think the way you presented that was right on. Yes.
Well, we better take a break.
Yes, I know.
Thank you so much, Vincent, for being here.
My pleasure.